A state's Department of Transportation plans to develop a new section of interstate highway and received 16 bids for the project. State plans to hire 4 of the bidding companies. Does it matter what order you select these companies? No, all that matters is which companies you pick. So that's the difference between a permutation and a combination. Permutation, you care about order. Combination, you don't. Okay, this is called a combination. So on this one, you would take 16 factorial, just like before, divided by, what, 12 factorial? Just like before, that n minus r. And then also divide by 4 factorial on the bottom, because that gets rid of the order. So if you put this in your calculator right now, 16 factorial divided by parentheses 12 factorial, 4 factorial. $1,820. Combinations. Which, Georgia, now you are on the in, and you know that the word combination lock really makes me angry. Because it's not like you can put them in any order. It's a specific order, which is called a permutation, not a combination. A combination is just picking some. So it'd be like if I was like, I got to get into my locker, I know my code is 29, 5, 12, but I could just put them in any order I wanted, as long as it was those 3 numbers. That would truly be a combination lock. These are permutation locks out here. Nobody cares about me being mad about this, but I have always been mad about it and will continue to be mad about it. The formula is n factorial divided by parentheses n minus r factorial, and then r factorial also on the bottom. This is n choose r, or n combination r. So you could put it in your calculator like this. You could also write 16 and then go to math, over to probability, choose the NCR button and write 16, choose 4. You'll also get 1,820. Por ejemplo, 10. Find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. Okay, so if you're dealt 5 diamonds, do you play card games? Not at all? Okay, well, this is gonna be rough then. So if you're playing a card game, raise your hand if you do play card games. Okay, when you play card games, you can rearrange the cards in your hand. Are you good with that? You understand that? So like if I drew 5 cards and I was getting like a straight in poker, which is like 2, 3, 4, 5, 6 numbers in order, but doesn't matter what suit. It's not like if I got a 2, 3 in my hand, a 2, 3, 4, 6, 5, I wouldn't be like, oh man, if only these 2 cards had been switched, I would have had a straight, but I guess now I got nothing. Like I would just take those 2 cards and switch them. So it doesn't matter what order you draw them in, it just matters what you get, which is why every single time it's a card question, it's usually a combination question. So find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. It's a probability, so there's a fraction involved. On the bottom, there's 52 cards, and we are choosing 5 of them. So that's the number that's going to go on the bottom of the fraction. How about the top of the fraction? Anybody? Well, this is the total cards, and then I'm trying to think, so it's like out of the total amount. Okay, let me write it this way. Everybody put 52, choose 5 in your calculator. Okay, this is how many different ways there are just to choose 5 cards. And now, on the top of the fraction, on top of the proportion, I want to write how many different ways there are to pick 5 diamonds. So on the top of the fraction, all I care about is 5 diamonds.
13, choose 5.
Yes, there are 13 diamonds, and I want 5 diamonds. And then you divide those two. I got 4.952 e to the negative fourth. What does it mean when it says e to the negative fourth?
Scientific notation.
Mm-hmm. Which means what?
If it's a negative 4, move the decimal.
Move the decimal to the left, yep. 1, 2, 3, 4, so it'd be 0.000495-ish. That is your chances of selecting, first try, 5 diamonds at a time. That's called a diamond flush, by the way. Example 11 says a food manufacturer is analyzing a sample of 400 corn kernels. Now, this seems like a very stupid question, but this is actually one of the most common kind of questions in statistics because they're trying to create like a testing scenario in engineering where they're trying to see if their procedure will catch mistakes. So they'll do something like this where they'll say, look, we've got 400 corn kernels and three of the corn kernels have dangerously high levels of this toxin. What are the chances that we get one kernel that is toxic? Because suppose that you have 400 corn kernels, obviously you're going to have a lot more than that if you're dealing with corn, right? So a small percentage of them will be toxic. So the question isn't necessarily, is the test that you're doing going to detect the toxicity, but also what are the chances you even get toxic kernels when you're testing them? Like, you could get some normal kernels and then test them and then be like, oh, looks like we're fine. And then it could just be as simple as saying, look, if there's just such a small chance that you're actually going to get a toxic kernel in your thing, then you need to do the test 10 times in a row, because the chances of you not getting a toxic kernel 10 times in a row